Hello class, welcome to our lesson today dealing with section 10.5. This is our second lesson dealing with dependent and independent events. To be honest, I have a little shorter lesson today because I want to make sure there's time to work on this section. We got to make sure that our probabilities are lined up correctly. So let's go and get started here on a few review questions. First one is find the scale factor. Remember, scale factor has to have the same units. So if I change the 2 feet into 24 inches, what I have is 6 inches over 24 inches, which becomes a simplified version of 1/4. What that means then is that the scale model is 1/4 the size of real life. The whole point of the scale factor is to get something where the units are the same, so you can think about how much times smaller or larger the object is compared to it in real life. Second one, you can just cross multiply, so do 10 times x equals 7 times 28, and then divide by 10 on both sides. You should be able to cross multiply at this point in the semester, so make sure you're able to do that. Okay, these are the two things that I asked you to write down from your last assignment. When you have independent events, to find the probability of both events occurring, or even 3 events occurring, it's just probability of the first times probability of the second times probability of the third. We've been working with that over the past couple of lessons, but it's just going to be more clear then as you're looking at those situations. For dependent events, it's the same idea, but it's the probability of the first event, and then times the probability of event B after event A has occurred. So if they're dependent events, you have to assume the first one has happened and then adjust your probability based upon that action. So here we go. Here's spin a spinner. So the spinner's over here. It's got 5 sides. Flip a coin, then roll a 6-sided die. So these are independent events. One does not affect the other. So we just find the probabilities individually and mash them together. So spin a 4, 1 out of 5, because one of the 5 numbers. Flip tails, and then roll a multiple of 2. Roll a multiple of 2 would be 3 out of 6. You could write that as 1/2 because half of the sides of a fair die are are multiples of 2, which also corresponds to the evens. I multiply all that together, simplify my fraction, I get 1/20. Now this is completely happenstance that the second one also ends up being 1/20. Spin a prime number. Remember, the number 1 is not prime, so 2, 3, and 5 2, 3, and 5, which would be 3 out of 5 numbers. Flip heads and then roll a 4. I multiply that across. You could cross simplify the 3 and the 6, for example, and you should get 1/20 as a final answer there. Notice all this is multiplying fractions together. So you just find the 3 fractions, multiply them together, and then that would be your final answer. This one says draw a tile from a bag, one for each letter of the alphabet. You're going to draw one, place it on the table, then draw another one. That's the idea of drawing 2 at the same time or without replacement. So this is pick the letter J, so 1 out of 26. Then the letter H, 1 out of 25 because the letter H is still in there, but there's only 25 to choose from because you took 1 out. And that would give me 1 out of 650. It depends on the question, but I would say let's keep working with the fraction ideas. I think that's the easiest to grade and the easiest for you to see what's going on and for me to see what's going on. So I think fractions are the route to go in these cases. Pick a vowel, that's 5 of 26. Now here's the key with this piece. There's still 21 consonants, so don't assume that it's just going down by 1 every time in the numerator. The denominator should go down by 1 because you have 1 less option to choose from. Some people mess up and try to put 21 in the bottom here because they say, oh, all the vowels have been picked. Remember, you've only picked 1 vowel, and then you have the 21 consonants still there out of 25. I cross-simplified the 5 and 25, and then simplified down to 21 over 130. Pick a letter in the word Baltimore. There's 9 letters out of the 26. Times 1 out of 25 for the letter Z, because one of the letters from the word Baltimore were out, and then only 1 letter was gone, so I'm still out of 25. And then 9 times 1, 26 times 25 would equal 9 out of the 650. Maybe this has happened to you. You have an upcoming test, but it's multiple choice. You didn't study, so you're just guessing on all of them. So this is assuming complete guess. Now, some of you are looking at these 3 questions and saying, how could you sit through the entire situation and miss all of these questions? Okay, for example, the year 1492 is probably not when the United States gained independence. But this is assuming you don't know anything about any of the situations right now. So when you're looking at this question, what you want to see is, all right, what's the probability to get the first question right just by guessing? So that should be 1 out of 5 because there's 5 options. Then the next question, 1 out of 5 to get that question right. And the next question, 1 out of 5 again. That ends up being 1 out of 125. That's less than 1%. Okay, so if you just go completely blind into a class, it would be like if I went into a class I've never been in and took the test. I'm just completely guessing. Okay, what happens here, though, is like this 1492 for letter A in the first question. you probably could eliminate some answers. So all of a sudden from 1 out of 5, it's 1 out of 4. You should probably be able to eliminate 2,000 as well. And now you went from 1 out of 5 to 1 out of 3, which is what teachers often tell people about distractor options and things like that for multiple choice questions. The goal is to eliminate as many as possible to increase your likelihood of getting a question right. So your probability is probably a little bit higher, probably much higher actually, because you know some things already about these situations that you could eliminate. You could get that from context clues, you could get that from the lessons, you could get that just from being in class and listening to the teacher, okay, or homework assignments, things like that, where you eliminate some answers and see what's left. Okay, your homework today is 1 and 2, 9 through 15, and 18 through 22 on section 10.5. You have got to make sure you show a setup. So what we don't want to see is just an answer. Like I'm glad you got the answer of 1 out of 650, but you've got to make sure you show the setup on all these questions. That's what the teachers are going to be looking at to make sure that we understand how you found your answers. So please make sure you do that. Make sure you have fractions, work in fraction cases. Okay, you want to be able to multiply those fractions by hand. Okay, I know the numbers sometimes get larger, but challenge yourself to try some of these questions without a calculator to make sure you know how to find them. Have a good day, everyone.